I'm not dreaming anymore. All that I know is I'm falling.
Okay, last problem, number 5. We're given functions p of x, which is equal to 1 over the square root of x, and m of x, which is equal to x squared minus 4. And we're going to state the domains of the following functions using interval notation. Okay, so let's work on part A first. So we have domain of p of x over m of x. So what does that mean? So p of x over m of x, we're simply just going to follow the instructions, okay? So p of x is given as 1 over square root of x. So that's our top function, and then we're going to divide it by, in big division sign there, m of x, which is given by x squared minus 4, okay? And it helps to think of x squared minus 4 being like kind of over 1, okay? Just so we can flip it up to the top and like multiply by the reciprocal, because dividing by a fraction is the same thing as multiplying by the reciprocal. So this is going to be 1 over square root of x times, and then 1 over x squared minus 4, okay? So overall, we get that p of x over m of x is equal to 1 over the square root of x times x squared minus 4, okay? So now our job, once we have kind of created this composition of functions of a sort, is to figure out, okay, what's the domain now? And just a reminder, domain means the range of, or the set of possible input values you could have for your function, okay? In order for it to be not undefined. In order for it to not be undefined. Yes, that's correct. So anyways, so basically, what can x not be in this case? What can x not be? So the first thing is, okay, we don't want the bottom to be 0. But denominator is not allowed to equal 0. Otherwise, that would give us an undefined function, right? Or an undefined point. And then also, we see a square root here. So inside the square root, we can't have a negative number, right? So we have kind of 2 restrictions here which are going to guide us toward our domain for part A. So we have that x must be, because of this inside the square root thing, x must be greater than or equal to 0. But it can't be or equal to because that would make the bottom be 0, right? So x has to definitely be greater than 0, okay? So that's given by the square root part, so we can kind of forget about that now. And now let's look at this x squared minus 4, okay? So x squared minus 4, when would that equal 0? That would be when x is equal to plus or minus 2, right? And it's definitely not going to be minus 2 because we can't have x being a negative number, right, as given by this. And so that means x cannot equal a positive 2. Because if x equals positive 2, that would make the bottom be 0, thus our function is undefined, and that's bad. We don't want that for our domain. Okay, so our domain is basically given by the following. So x is greater than 0, and x can't equal 2. So how would we write this in interval notation? Well, we can do the following. So x can't be can't be a negative number, and it can't be equal to 0. So we start off by using a rounded brace here, or a parentheses basically, and then we put 0, because that's our left endpoint. Okay, and we can go up to 2, but not include it, because we don't want it to equal 0. So this is going to be union, which means kind of like added on to, another interval, which is given by rounded bracket, or rounded brace, and 2, and then x can be anything greater than that, right? So this is our domain for the first one here. So this is our domain for part A. Alrighty, now for part B. Now we're trying to find the domain of P of m of x. Okay, so here we do see this is definitely a composition of functions because one function is serving as the input to another function, right? So what do we have to do here? So m of x, like I just circled, that is our input into P. So what we're going to write is kind of like the outline of what P is, our function P. So this is 1 over the square root of whatever our input is, right? So our input in this case is going to be our function m of x. So that would be x squared minus 4. That's where we're inputting, or that's what we're sticking in for the input spot, right? So this is our function. It's pretty simple in the sense that it doesn't have like a bunch of terms floating around on the bottom. So what's our domain now? What are the restrictions? We don't want the bottom equal to 0. We don't want this equal to 0, right? So, and we also see actually that we have a square root on the bottom. So we don't want it to be negative either. We don't want the inside to be negative. So we want it to stay positive. So above 0, and normally it could be equal to 0 because like taking the square root of 0 is just 0. So that doesn't affect anything except for our square root happens to be on the bottom, so it has to be strictly greater than 0. We can't have this or equal to sign because that would make our function undefined. Okay? So anyway, so we're just going to solve this inequality. Right? So we get x squared is greater than 4, which means that when you square root, we take the absolute value, right? So this absolute value is greater than a 2. Okay? And to break this down, we just have that, well, the absolute value must be greater than 2, so either x must be greater than 2 and or x must be less than negative 2. Okay? So how do we write this in interval notation? This would basically just be, well, you can go from negative infinity up to negative 2, because that would mean less than negative 2, right? And we're going to union, or kind of add it to another interval, which is 2 up to positive infinity. Okay? And that is the domain for part B, for our P of M of X. Okay, so that does it for our homework, or our practice problems video for the section on composition of functions. I hope that helps, and good luck on your homework.
All